Welcome everybody. This is the fourth talk of the morning session, UGM2020 on Wednesday. This is Claudio Cacciari. He's going to talk about iRODS and Federated Identity Authentication that he's doing at SURF. Go for it.
Hi, yes, this is my topic for today, and I'm working at SURF, as Jason said. Let me change my slide. So SURF is a collaborative organization for ICT in Dutch education and research, and offer multiple computing and data services to multiple organizations, both member and not member of the SURF consortium. And in particular, among the multiple services, there is a service based on iRODS, which are connected, used by different organizations. And one key aspect, of course, of using multiple services from multiple organizations is the security part and the authentication. And that's what I will show more in details in the next slides. About the collaboration between SURF and this multiple organization, you can have more details tomorrow during the presentation of my colleague Saskia at 10 about the RDM infrastructure in Netherlands based on iRODS. So in our environment, in our context, we have multiple identity providers. Each organization has own identity provider and want to that the user is able to log in to SURF services using its own identity. For all the organization, this is desirable. For some of the organization, it's really mandatory, and so it's also mandatory for us to provide this feature. SURF has already a tool for managing the federated identity and access management. And we would like to support this tool and this approach also for iRODS-based services. So my team is responsible for research data management services based on iRODS and offer these services in different configurations. So just an example here, sometimes, so we offer iRODS instance dedicated for each organization. And sometimes we host the full iRODS software stack with the iCAT and the resource server and everything on SURF premises. Sometimes university hosts some of the components like the resource server connected to an iCAT at SURF. Sometimes the opposite, so university hosts the iCAT server and at SURF we just expose our hardware resources through a resource server. So in any case, in all these different configurations, the common aspect is that the security need to be managed with careful, and the university really want to have that their user, the researcher, friendly and transparent way, let's say, to use the services. So also the authentication should be as smooth as possible. So in particular, I'm now describing the main use case driving our proposal here for a federated identity support from iRODS. So let's say a typical case is one, there is a research team, in this case the George research team, and a researcher want to join the research team, Mark and Stefanie in this case. And the data are already available in iRODS in some folder. And so Mark wants to access this data through some web interface, web portal connected to iRODS. So in this case, it is, of course, as I said, desirable to be able to access it through a federated identity. So through the web portal, typically the user selects the option for using its own home institution identity. And then it's redirected to the login page of the identity provider of their own university, login, successful, and then redirected back to the web interface, where typically there is a graphical interface that show the content of the iRODS folder, in this case called archive. And that's it for Mark. That would be already good achievements. And then there is Stefanie. Stefanie wants to connect to the same folder of George research team, but through iCommand, so through terminal, entering a username, password, and then able to see the same data visualized by Mark to the web user interface. In this case, it's one of the requirements that Stefanie can log into its own home institution credential. And so, going to more detailed, what is behind this user pattern, user stories that we have shown. So in one case, in the case of Mark, iRODS is working as a backend, so behind a web application. And well, typically you can, of course, already enable with the current iRODS feature this approach. For example, creating an administrator user with privilege, so that the web app can basically act on iRODS on behalf of multiple users, or implementing something like sudo-like microservice that allow the web app to become or act on behalf of the user for some operations. So in this way, you would provide a friendly experience for the user, a single sign-on. The user it is not requested to log in again to access iRODS. But this approach has some limitation, in particular from the security perspective. Of course, if you give administrator privilege to an external web app and the web app is compromised in some way, all iRODS is compromised, because of course it's connected in that way. And with sudo-like microservices, again, you can of course limit more the access, but if you want to have flexibility on the web app in order to perform various operations, you end up more or less in the same situation as the administrator privilege. So you have security limitation, and then this protocol typically are not very suitable for federated identity management. And well, it's not impossible, but at least problematic to keep a consistent audit track with this approach. And so we can also, of course, use widely adopted solution for this kind of web application like SAML or OpenID Connect. That's possible. We can generate a token and pass the token to, for example, iRODS via PAM, and use a PAM OAuth2 module in the backend of iRODS and validate the token and authenticate. Yes, that's possible. Again, that's this kind of protocol, SAML and OIDC support federated identity management and also single sign-on. So that would be fine. And we also would have a consistent audit track, so we are really able in this way to log who is doing what in the system. So apparently that's found the solution, but no, not yet really. So even token-based protocol can have limitation. Token can expire. iRODS is not aware of the token expiration. And even if it were the refresh token to renew, the token is typically in the web app and not in iRODS. So, and only the web app can renew it. So let's say the whole process is not really straightforward. And moreover, iRODS in this way would keep using a password, a scrambled password stored in the iRODS client side. And typically this password would outlive the token lifetime, and yeah, the risk is to creating a new security breach, basically. Then we have Stefanie. We want to, that the authentication of Stefanie, it's user-friendly and supporting federated identity management, like in the case of Mark. So we would like to use OIDC and SAML also in this case. And we have indeed already, there is already a plugin for supporting OIDC with iRODS. Again, with some limitation, this plugin allows you to authenticate at command line, but if you have iRODS as a backend and a web app passing just a token, well, this is not supported at the moment. And then also another point is that you need to fix the authentication protocol on the client side. So you need to tell the client, I want to use OIDC to authenticate. Which is fine in most part of the cases, but not all. For example, if you have a shared client, like, for example, iRODS interface, you could want to have the support for multiple authentication protocol without the need to change every time on the client side, this parameter, this configuration. Why this? Because at least in our environment, we have scenarios in which we need to support multiple authentication protocol within the same iRODS instance. And so not all the organization that use this service as FIM, Federated Identity Management Protocol. Some just use LDAP or Active Directories, Kerberos, these kind of things. And it's really convenient for us to use PAM, so pluggable authentication modules to support these different authentication protocols. We can stack multiple modules supporting different authentication modules in the backend of iRODS, and the PAM works in a way that the user authentication fall through the various modules, basically. So if the first module fails, it can check automatically with the other modules, and so the user does not need to select in advance the authentication protocol, just the authentication, go through the various modules until match something or deny the access, basically. So that's why our proposed solution to solve everything of this problem is OIDC with PAM. And so, yeah, Stefanie can authenticate using INIT, but using the OIDC protocol. And yeah, what we can expect is that Stefanie receive a message on the shell, on the terminal, saying, please copy this URL in your browser. She copied the URL in the browser, got back another message. I authenticate with IDP provider like Mark did before with her own home institution credential, successful, redirected to another page and get a message, or in this case, a callback URL, passed this message back to the terminal and complete the authentication process. That's the idea. So in a more high-level overview, this is the process. So we do not want to disrupt the normal OIDC code flow. The standard OIDC code flow is still there, and we will not touch it. We will work a bit more in the iRODS part on the way to authenticate the user supporting OIDC with PAM. So PAM OIDC module, in this case, it's a client for OpenID provider and manage all the OIDC operation, basically. And the PAM module is able to pass to messages back to the command line, which with the user that react and answer to the various challenges provided by the authentication mechanism. So far seems perfect, so problem solved. But no, not really. Well, this is the same overview that I have shown now, but in a more canonical OIDC sequence diagram. So for the people in the audience familiar with OIDC, this is how you can see it, mapped it to it. And also another point of attention with this approach with PAM is that basically you have multiple user attributes database, and you want to synchronize them to iRODS to have a consistent namespace. And So you need to have a synchronization point in front of iRODS for all this account to avoid conflicts for user namespace, basically. So the problem that I mentioned about our approach is that at the moment, with the current iRODS configuration of PAM module, it's not possible to send back to the client if they need any challenge, any message. That does not work. Or in the sequence diagram, yes, the login URL back from the iRODS catalog provider is not going passing through. Okay. So yeah, as I said, this is not working in the sense that technically iRODS PAM current module is not supporting a full PAM conversation. That's how in the PAM jargon is defined. And then we need again to decide what to store on the client side, because there is no password anymore in this case, but a set of messages, let's say, or token. So we need to define what we want to store on the client side. So to overcome this limitation, we come up with the idea to have a sort of PAM enhanced. So we patched iRODS, the client side, to support an arbitrary exchange of message with PAM module. And also we patched the server side, introducing an auxiliary service which is able to support a full PAM conversation. And yeah, in this way we are able to implement our proposal. At the moment, it's just a proof of concept, and as I said, yes, we have patched the iRODS code. It has been a good way to start testing it with our user. However, we have no intention to maintain a patched version of iRODS on the long term. Our objective is to converge towards a general solution with the iRODS community and the iRODS consortium. So, and yeah, so we welcome really the proposal from the iRODS Authentication Working Group of this new API endpoint. They proposed to define this API endpoint to provide the flexibility that we need to support this exchange of messages. And the messages in the current proposal are defined as JSON document, and there is a proof of concept developed by JSON. It supports the native authentication of iRODS, so additional authentication protocol based on PAM or OIDC need to be developed, and some effort is needed from the community. And yeah, also we need to decide yet how to store the responses on the client side. And moreover, this approach is client-driven, so each client will have to explicitly support and implement this change. And yeah, so the next steps from our perspective for our team in SURF, it's really to, as I said, converge, so to use the code that we have already developed for the proof of concept and try to merge it in or to implement it within the new iRODS API. At the same time, we are going on with tests with our code, with our users. So we have these two parallel activity, one to consolidate our code, and the other is to try to converge and merge it in the new API. And I want to thank my colleague of my team, Stefan Wolsheimer, the developers of this code that I mentioned, and all the other team member, and for the contribution to this proposal. And that's it. So if you have questions, now I think it's the time.
Excellent. Thank you, Claudio. So in terms of, yeah, I know that you've got two development processes going on in parallel. That seems complicated. It does seem like it's converging at this point, though, I think. Is that correct? In terms of the use cases that you've got and the things that we've been working on in the working group?
We want to make converging, depending, so we have also some time constraint to deliver this feature to our user. So depending on the maturity that the work, the task from the working group and our work reach together, we can decide of, let's say, to give priority more or our internal proof of concept,
Sure.
or the merging with the working group. So let's say, if we see that the activity with the working group is growing up quickly and reaching quickly a good level of maturity, we could go with directly with the merging with the working group. But if the activity on the working group require a bit more time for consolidation, maybe we can try to just, in the meanwhile, go on with the internal solution.
Certainly, certainly. Jason Koposki asks if you could elaborate a little bit on the storing of information on the client side. I think that's new information for us.
Well, basically, iRODS has no concept of a session, right? You
Right.
store the scrambled password in the client when you authenticate, right? But in the case of this exchange of messages, you exchange, as I show as an example, some URL and a string back. It can be a token, can be a different string, and that's it. And so I'm wondering, the other iCommand that rely on the fact that you have some password already there to not, because iRODS authenticate every time for every command, right? So what we should store on the client side, we do not have the scrambled password anymore in this case, in this OIDC. Maybe we can create a token, that's a possibility, and store just a token that's iRODS understand on their side, on our side, and say, okay, if this token is there, the other iCommand can go on, can authenticate as usual. I don't know, this is just an idea.
Right. There's a comment from Emir James in Barcelona. He says the worldwide Large Hadron Collider computing grid, WLCG, had a similar authentication and authorization problem because they've got, you know, tremendous number of people across a tremendous number of organizations. It says it might be useful to see what they've done there. It's based around each organization setting up a trusted CA and a user to import their private keys into their browser. And so that's another possibility of approaching a multi-institutional opportunity. Call them problems, call them opportunities.
Yeah, true also.
I think that's all the comments and questions that I see. Is there anything else anybody would like to ask, raising their hand? Raja says we can just use cookies for everything. No, I think we're good. Well, thank you, sir, and great work, and we will continue the conversation.